Alright, welcome back to another video, and today we will be working the January 2014 Mathematics Paper 2 Question 7, which is on statistics. So here it goes. So it says the heights of a sample of seedlings were measured to the nearest centimeter and then arranged in class intervals as shown in the table below. So these are our class intervals: 3 to 7, 8 to 12, 13 to 17, 18 to 22, 23 to 27, 28 to 32, 33 to 37. So just a little background information on this section. So you know these are class intervals. We know that our class intervals are made up of lower class limits, which are the first number in each class interval, and upper class limits, which are the last numbers in each class interval. And we know that we have terms such as upper class boundary and lower class boundary, where each is either 0.5 lower than or 0.5 higher than the respective class limits. And to calculate class width, it is just the difference between the upper class boundary and the lower class boundary of any of these class. So let us go. So question A says, how many seedlings were in the sample? So for us to calculate the seedlings, what we know is that the total frequency is always equal to the total number of sampler quantity. So therefore, to get the total, how many seedlings were in the sample, all we need to do is to add the frequencies of part A. Total seedlings is equal to total frequency. So therefore, that is equal to 0 plus 3 plus 12 plus 16 plus 22 plus 18 plus 40. And when you add those, what you'll get is 0 plus 3 dot. The total frequency is therefore equal to 85. So there were 85 seedlings. So 85 seedlings were in the sample. So remember, your total frequency is always equal to the total amount of quantity that is given in the question. Part B now says, for the class interval written as 8 to 12, so we're interested in the second class interval, 8 to 12, they want us to write down. So we're now on to part B. So part B1, they want us to write the lower class limit. So lower class limit is equal to, I just explained what that is. So the lower class limit would be 8. If that asks you for the upper class limit, it would have been 12. So that is part 1. Part 2 asks us for the upper class limit, upper class boundary. So I stated earlier that with boundaries, so for the lower class boundary, it would have been 0.5 lower than the lower class limit. So the upper class boundary is 0.5 higher than the upper class limit. So upper class limit is 12. So therefore, upper class boundary would therefore be 12.5. So 12.5. That is our upper class boundary. Part 3 now asks us for the class width. So we can use class width. So remember, we still have to use information. So there are two formulas for class width, but the one that we're going to use is the boundaries, the one that contains the boundaries, because it says for this entire section we're using the class interval of 8 to 12. So therefore we're going to say class width is equal to the upper class boundary minus the lower class boundary. So there's some shortening of spellings, everything can be in one line. So using lower class boundary. So it is the upper class boundary minus the lower class boundary. And that is the formula. So therefore, what that will be equal to is, so class width is equal to, we know what the upper class boundary is, which is 12.5. And as I said, the lower class boundary will be 0.5 lower than the lower class limit. So our lower class limit is 8. So our lower class boundary would be 7.5. And therefore, we can now go ahead and calculate our class width. So therefore, the class width is equal to 5. And that is our answer. So going again nicely. So that is very good. Part C now says, copy and complete the table by inserting the midpoints of each of the class intervals. So let me just show you. So part C. So what they use, a formula that you can use to calculate the midpoint is basically the limits. So you're going to add the limits and divide them by 2. Or you can add the boundaries and divide them by 2. So any one of those formulas, you can either add the limits and divide them by 2, or add the boundaries, so the lower class boundary and the upper class boundary, and divide them by 2. So if we should go, so it says complete. So let's look at the first 3 that they did. So this is C part 1. So we're saying we can do midpoints is equal to, so we're saying lower class limit plus upper class limit, and we're going to divide that by 2. So if we should look at it, so for the first one, what we'll have is, if we have midpoint is equal to, so what we'll have is 7 plus 3, and that is divided by 2. So that would be 10 divided by 2, and that is equal to 5. So we see how they got the 5 there. For the second class interval, so the midpoint is, therefore, it would have been 8 plus 12 divided by 2. 8 plus 12, that is 20 divided by 2, and that is equal to 10. So our third one, so midpoint is equal to 13 plus 17. Let's put our brackets. So it is 13 plus 17 divided by 2. So 13 plus 17, that would equal to 30. So it is 30 divided by 2, and that is equal to 50. And then we're moving on. So let's just extend this a bit. So we get the gist. So that is what we'll be doing for the others. So we see, so next we'll have 18 and 22. So you get the gist, so we don't have to write the others. So writing the midpoints. So what we'll have, therefore, is 18 plus 22, that would equal to 40, divided by 2, and therefore our midpoint for this would be 20. So our midpoint is 20. Next we have 23 plus 27, and that will give us 50 divided by 2. That would be a midpoint of 25. Next we have 28 plus 32, that will give us 60 divided by 2, that will give us a midpoint of 30. And then next we have 33 plus 37, that will give us 70 divided by 2, and that will give us 35. So we've completed that. Part 2 now of C, it says write the missing values for the class interval after the interval 33 to 37. So that would have been, following the trend, it would have then been 38, the 38 to 42. This is a 38. 8 isn't writing properly. So 38 to 42. So therefore, our midpoint for that would have been 38 plus 42, that is 80 divided by 2, that would give us a midpoint of 40. And basically your frequency here would be 0. Now, what I want you to look now at part D, it asks us to calculate the frequency polygon. Now, what I want you to remember is that when calculating frequency polygon, the points on your frequency polygon, it needs to be closed, and it is closed when it touches the horizontal axis. That is when your frequency polygon is closed. So therefore, usually we'll need to assume or estimate the class interval, and basically the frequency would have been 0 for these estimated classes for the one that is before the first class interval. So in this case, they gave us what, 3 to 7. So we'll need to estimate the class interval that is before that, and then the class interval which is after the last one, which is 33 to 37, which is what we did here. And that is how we know what our point is. Basically for this one, it would have more than likely been 0, 0, or I'm guessing that is why they gave us this. So this is where our graph should have really started, which is from the 8 to 12 interval, and then this one is what we would have assumed. So these are the points now that we're going to use to plot our frequency polygon. So it says, using a scale of 2 centimeter to represent 5 centimeter on the horizontal axis and 2 centimeter to represent 5 seedlings on the vertical axis, draw a frequency polygon to represent the data as shown in your table. So the points that we're going to be using is the midpoints and our frequency. So we have our midpoints and our frequency here. So we'd have the one that we're going to use to close off our frequency polygon would have been the last class that they asked us to assume, which had a midpoint, we say, of 40 and a frequency of 0. So both frequencies are 0, and that's what we'll use to close off our frequency polygon. So now we have our scale 2 centimeter to 5 centimeter on the x-axis, 2 centimeter to 5 seedlings on the y, which is our frequency, our x is height. So we have a midpoint of 5 with a frequency of 0. So that will be right here. Next, we have a midpoint of 10 with a frequency of 3. So this is 10. So 3 would be somewhere around here, because this line would be 2.5. Then next we have 15 with a frequency of 12. So 15 with a frequency of 12. So that would come a little bit below that line. Then we have a midpoint of 20 with a frequency of 60. So that would be somewhere here. Next we have a midpoint of 25 with a frequency of 22. So 25 with a frequency of 22. Then we have a midpoint of 30 with a frequency of 18. So that would start declining. So that is 20. So 18 would be somewhere here. Then we have a midpoint of 25. Alright, so that shouldn't be 25. Let's go back to our table. That is actually This should have been 35. All right, so let's fix that. So this should be 35. So it is 25, 30, 35. So next we have a midpoint of 35 with a frequency of 14. So 35 with a frequency of 14. So that would be somewhere here. And then the one that we estimated a midpoint of 40 with a frequency of 0. So our frequency polygon is closed on the horizontal axis. Now we can go ahead, get to our ruler and draw straight lines to connect each point. And this is what our frequency polygon will look like. Yours will be way neater than this because you will have a ruler to connect the different points. So let's go back and see if that was the last question. Yes, it was 5 marks. So thank you for joining us, and we will see you in another video at another time. Please remember to like, comment, share, and to subscribe with a friend. Tell a friend to tell a friend so that we can all be prepared for it.